Okay.
And I've also just hit record.
Yeah, it's lovely. Oh, damn it, we're not recording.
I've just hit record.
Thank you. I thought I set this up to auto record. Yeah, sorry. Okay. All right. So chapter 3 and 4 in the textbook, with a whole lot of the case study and stuff worked in, is looking at, first of all, data collection, data acquisition. What are the rules or the real learnings that's out there, industry learnings about things that people have learned about how we collect and keep data and what we look for in data. And then what we're going to look at is your data analysis team. Who are the people? But more, because remember that this is strategic ICT management. This is not where we're going to do data analysis. We're more going to look at how do you hire. And I really like the data analyst Tetris. It's not the first time I've seen it. You guys will see it in the slide. It's used widely and it's very useful. Okay, so let's go. So this first slide, and that lorem ipsum there is on purpose. That was not notebook LLM. Okay. All right. So a question I have for you guys is, should you collect data consistently?
It makes sense to do it, I would imagine.
Yeah. So we collect data consistently. You should be collecting as far as you go. But there's this statement that says collect everything you can. And that you will be sorry if you don't have it. And we're going to look at those two sides of the coin today. That what is it? Should we collect everything you can? And where is it a statement, and where in practice is it quite difficult? And there's just some things that I want you to listen to what I'm saying now, and you're going to see that come up. And when we look at the case study of where these things come to play. So when we have information, we're actually looking for context. And what people are forgetting is context is king in data, especially where data is really used strongly. It's not really to support research. It's not really to change the way we see the world. It's to sell stuff to people. Okay, so their context becomes deeply important. So this is an example of where you get to context. It is when the user has an intent, and we're going to go deeply through an example of that. Then in that intent, what friction points comes about and how are they introduced? And we're going to look at that. How does that change the way they hover in a website? And how do we use all of these bits of information to get data about a person? But if we collect a whole lot of data, we have to think about a couple of things, okay? We have to be very careful because data pipelines cost money, maintenance costs money, but that's fine. We can deal with the money, but data integration, and this, I want you to put this in your ears for that case study. Data integration is quite a thing. So if we're going to start collecting masses of data where we can get to a granular individual level and look at user behavior, we have to be super careful how we collect that data so that it doesn't, instead of becoming our best tool, become the biggest pain in your rear end. Okay. So an example is that if you have all different data sets, like if you have different HR data sets, sales data sets, production data sets, and they all look different, that's pointless. You cannot bring that data together, or to bring it together to do the integration is going to take very, very, very long. So when you start looking at mass data collection, you have to set your rules, your structures, what that data is going to look at first. You better have a plan or you're just going to pay for storage. Am I making sense? Do you guys have any questions? Sorry, Michael. Okay.
Hello.
All right. Okay, you're also not supposed to see that at all. Okay. Right.
Post a comment in chat.
Oh, I missed your comment.
It's all good. It's frivolous.
Let me go find it. Yes, smart hydro is a user intent, Barry, quite literally. It's a research study we're running at Varsity College. It's a hydroponic grow tents, and it's...
Emerus, not Varsity College.
Damn it. It's people in the tent. Okay. All right. So there are a lot of buzzwords that we hear with data, and there's a lot of things that people say. Okay, so if we're going to collect massive amount of data, which is where we're going, if we're going to be smart at it, these are the words that you're looking for. It's the 3 V's. Historically, they've spoken about the 3 V's of data. However, the 4th V is one that you have to derive by how you do your data. So the one example that they're going to talk about is volume. So storage is consistently getting cheaper and cheaper. Okay, so storage solutions online is consistently getting cheaper and cheaper. However, it is easy to hoard and hard to process. So if we have massive amounts of data, it's going to become really easy for us to hold this data and really hard to process it. Okay, and actually 90% of the data in the whole world has been collected in the last, like 21st century, in the last decade. And do you guys have any idea how much data on average a person on the Google fabric and infrastructure pushes to the cloud through their phone? You know, if you have an Android phone, it actually backs up to Google. Do you guys have any idea of the numbers and metrics of how much you as a person with your phone pushes up to Google?
Not
Into
all of
your
it's stored though, right?
Oh, yeah. So if you think about my phone, depends on your settings. If you think about my phone, what goes up for me is I absolutely, as someone who should know better, get the, have you looked at your Google Maps timeline? You've been here, and here email. Have you guys ever had those? Those are super freaky. And you go like, I feel so violated. All my
I keep
photos are
that turned
backed up.
off. I keep like search history, YouTube history all off. So yeah,
So Barry, you are the customer that will sit between 700 to 900 megabytes. That's where you sit. I 100% sit in the gigs. And then basically the Android infrastructure sends hundreds of exabytes a day in storage. And Google is actively collecting and mining that data. We all know this. And they own the storage. So, and
can
they
you level the
will.
playing field and just tell us all what an exabyte is? I do know what it is, but I think everyone
Oh,
else
I
on the
can't
call would
remember what an
benefit from it.
exabyte is.
It's an
Big.
obscene number.
Can you guys go Google exabyte?
So after terabyte, it's petabyte, and then I think after
Yeah.
petabyte, it is exabyte. So
And then where does zettabyte come in? I think it's after petabyte.
Yeah, it's like big stuff. I gave up at gigabytes. That's what's been, I mean, when I got my first laptop, I had a 40 gig hard drive and I was the queen of the company. So don't talk about it. Yeah, so dark times. Yes, but that's the amount of data that we are dealing with. And actually, if you ask of the hours I spent compared to previous weeks, yeah. Listen, Ephraim, there's no shame in loving your phone. Yeah, so that's the amount of data that Google is playing with. And actually, if you ask LinkedIn what is considered a small record, my first piece was a 20 megabyte hard drive. If you ask LinkedIn what's considered a small data set, they'll say anything less with 100,000 records they consider for deletion. So this is where we play with, should we collect everything? But when we collect everything, then we have to look at the volume, like where we're going to put it, how does cost, is it easy to hoard and hard to process? But then the other part comes in, and that's velocity. Okay, so velocity is how quickly does that data need to be processed? Do you guys remember the election scandal in the last election when the data dashboard went down? Do you guys remember that? Yeah, I know, Michael, but I need my Google images. So do you guys remember that last year during the election was almost contested because for a couple of minutes that data, that the election dashboard went down. What is in your YouTube channel? Only my
yes,
slides.
they also were not able to use the handheld devices to register voters, or not register voters, but to record voter roll.
Yeah,
So they had to do it all manually at that point.
Yeah, so do you guys know what actually caused this? So I was in the governmental thing where the guy that works for the ICC, and now I can't remember his name, he is super interesting to listen to though. He was discussing this particular case, and what caused it was a velocity. He was saying they were updating every hour, and then the politicians came in and they were like, we need real time, we need this faster. And he said, in his infinite unwisdom, he told the development team, is it possible? And they said, yes, just do it. And when they pushed that change over, they accidentally crashed the dashboard, causing an international incident. And I enjoy him. I said, what's his name? We'll look him up. I enjoy him because he was like, I was thinking to myself, it's the Russians. It's happened. It's the Russians. Until the developers came and said they didn't tick the display flag. It's literally it. They had a display flag to not accidentally display stuff, and they forgot to click it. And it's because, and that's the complexity that we work with. But with velocity, is when we need real-time sentiment, then we also have to think about how much data, how valuable and how fast we need to process that data for cases like this. But what we need to get to as well is variety. And we're going to talk about that at length, and you're going to see that in the case study as well, is that we need to collect a variety of data. And we connect that variety of data to do inference mainly on people. Okay, so you have to have a coherent strategy because resources are constrained. You have to understand what can you store, how long can you store it for, how fast do I need it, how and what variety should it be, and then also how do I get that data back. Okay, so they're going to tell you that Google storage stores up to 1 trillion photos a day as is stored on your Google images. Okay, so of those, in those images, if you look at the data just a phone sends, a phone will send data in different formats. You'll have photos, you'll have GPS, you'll have app logs. So also what we have to start thinking about when we're thinking about how much data to collect, where do I collect it, how fast do I need it, is what the hell does this data look like? Because at some stage, I need to bring this data back together. Okay, are you guys all right?
Yep.
Okay. That's just your outline for your course. It's just every module and it's nothing bad. Okay, right. Okay, so value is the hero metric. Value is, even if I have ample storage, I can get that data fast enough, and I have got a rich dispart data in that's not going to cost me a lot of money to integrate it because it's not in JSON, XML, an FTP server, a photo, and somebody's text file. It's not going to cost me that much to integrate. Still, does it deliver value? Is all of that work enough? Does it give me what I need to know? So it's how do we decide to have our data provide value? And value is does it solve a business problem? Does it answer a question? So there are some rules. We obviously want return on investment. So we need to look at data. What is the immediate business impact of the data that we're keeping? So that's your ROI over here. And what's the implementation difficulty of that data? And then you really want to prioritize data that satisfies multiple business owners simultaneously. And you will see through later in this, we're going to start talking about what is an institution or a company's core data. Okay, so there's some quick wins, okay, that we can work with. And the quick wins are, it's low effort, it's super easy to get, and you can reuse it. It's already in APIs, it's already in microservices. So an example that we have of a quick win that I use all the time is something like that. So this is Open Weather Map, and you can see I use this. And then this is the Open Weather Map API that we can pull weather data to feed the hydroponics tents that we work with very, very easily. You just sign up and you can come and pull different weather data. And what makes Open Weather Map a quick win is that it is free. The data is super, super accurate, and that it is always in the neatest, cleanest JSON that you could potentially ask for. So all you have to do is sign up. You can pull this data. It's a community-driven initiative. So this is an example of a quick win for me in research. So you'll see there's an API call, and you just add your API key into it, and you can see the data. Also, what's really nice is this platform is set up in such a way that it's super easy to pull this into Android apps. It's super easy to pull it into microcontrollers. It's done very, very nicely. Whoever has done this is clearly a person that has taken their time. So these are calls that you can, parameters that you can give the API, call your latitude, your longitude, your API key. You can tell it to exclude things, like what is optional. You can give it the units that you want the information in and the language. I don't have an API key current, so I would have shown you an example of this API call. But very, very useful, very, very easy. That's a quick win. Do you guys have any examples of any data like this you use ever in your institutions or at your job? I keep saying institution. Where you work, do you guys have any free APIs or any stuff that's low effort, low cost, reusable, super nicely done? Nothing? Yeah, okay. Sorry, that's painful. Okay.
Does Marufa not have the smart meter APIs?
Marufa, do you guys have APIs?
Yeah, we actually do.
Are they for Mahala, or do you guys create and host them?
We have companies that create and host them for us.
And host them for you.
And I think for the meter reading app, one is actually hosted in SAP.
Oh,
They're trying by all means to integrate everything into SAP. But for the smart metering, it is outside of SAP and it has to synchronize in order to bring information. We do have a bit of challenges sometimes when the modems are off and stuff, but yeah.
Yeah. Okay, you're going to have that with any service.
Yeah.
Ephraim's taking a dig at Advitech there, saying Advitech does not provide APIs. Okay, Ephraim, it's time to make your own. It's easy peasy. Okay, then there is quick ones. There's nice to have. So this is low return on investment, but also low effort. And that's normally archival data. So that, you know, an example that I have of nice to have but low ROI is Ephraim, this is one for you. Do you track MSRs? And please explain to everybody in this room what an MSR and a TPR is in this virtual classroom. What's an MSR and what's a TPR?
Thanks, Sarina. MSR is the module success rate. So you want to see the student who enrolled for that module and they completed the module at the end of the year.
Yeah.
So your KITSO will then provide you with that MSR, which is the module success rate for that particular year. And you can always compare to the other previous year, which then sort of helps you to, make an informed decision in terms of what is transpiring. Is it doing well based on the percentage? And the other one you said is what?
TPR.
TPR. Oh goodness, I don't think I know that. Maybe Barry might know.
Barry, do you know what a TPR is? Marifa?
I don't have a
Riku,
tracking
you
shoe.
lecture. Riku, what's a TPR? Now I can pick on Riku as well. You can type it. So MSRs is a nice to have, and we actually, and don't shoot me, Ephraim, and don't repeat this outside of this classroom. MSRs is a nice to have because MSRs tells us exactly how, and then we celebrate MSR. So we'll go like, oh, we have an 80% module success rate. But then we go look at the throughput rate, as in how many students register and how many students complete. And then we get like 30%. And we do not know how those two relate. We haven't delved into it. So for me, I don't even look at MSRs. Like individual model success doesn't help me at all. The throughput rate is what we should be looking at. So for me, MSRs are nice to have. It's nice to make a quick decision of a lecturer's progress. It's nice to have a look at are the class doing okay in this particular module, but does it have a massive impact on how students graduate? Actually, no, because all of our module success rates are very high, but our throughput rates are not. So for me, that's a nice to have, and we spend an inordinate amount of money on it. Yes, Ephraim, you're not allowed to tell anybody I said that, especially the kids team. Yes, Ephraim.
No, I know that TPR is, once you just said it now, I just recall, I've not used, but maybe just use the TPR and MSR. Just my observation, maybe the TPR might be a long term because you want to look at the student that enroll for maybe, let's say 2026, for example. Now you will not know because if it's 3 years, you have to wait for them to complete the 3 years, right? So that they can know, okay, they completed from the time they enroll. The minimum time is this. But maybe MSR might guide you as they progress to them, and maybe following year, and then you can able to see if they are struggling and whatever the modules that they failed, how do you then pick so that they can complete in minimum time. And I think it adds value, the MSR as well. It fit into your TPR.
Yeah. So Ephraim, you and I will have a long conversation about it, but for all my years working in data, I cannot prove that. Then it's not been proved. Okay. Then there is the must-haves. Your high return on investment, your urgent data, and it's often called streaming data. What does streaming data mean? It's not Netflix. It's data that can be lost. It's data that's available for a snap, and you have to take it. And examples of streaming data is like election numbers or stuff that election numbers is a bad example. Streaming data is stuff that It's truly needed. It delivers high value, but it's data that you have to capture and keep now. It's not going to repeat itself. It's not repetitive data. And then what lots of people fall into is the trap, low ROI, high effort data. So screen scraping is an example they give of that. I actually do quite a lot of web scraping, and you do know that you're going to work your butt off for that data, but that is where you get very dirty data and you're not actually even sure if it's going to work for you. So what you want is to find your spot here where you find data that has the highest business impact and the lowest implementation difficulty. So once you then have decided how big must this data be, how fast must it be accessed, what value must it actually give me, and what variety must it be, what are my quick wins, my must-haves, my nice-to-haves, and the traps. This is what really needs to happen with data. And this is where a lot of organizations are not quite getting to. So the example they have here is if they talk in your textbook about it, but we will look at the case study where this is real and live in South Africa. So obviously we all need data, okay? But we get that data. So if you were a PDDA student, you're thinking about a beautiful CSV file, or you're thinking about a Kaggle data set that you just download, but that's not how it works in the real world. You're going to get data from very, very different sources, and you have to connect the dots to get to an individual user level, okay? And you have to link adjacent data things to each other. So I'm going to take you through the example in the textbook, and then I'm going to show you some real learnings we had. Okay, so what you have an example here is they talk about Belinda, and Belinda orders a patio set. Okay, now you are a data analyst for the company, and they're going to tell you, okay, how did we get Belinda? How did this chick order the patio set? Then you go and you look and you go like, oh, okay, Belinda actually did a Google search. This user landed by us through a Google search for patio tables. Okay, and then when she landed here, she browsed 15, she was only here for 3 minutes, and she looked at 15 different patio sets. So she didn't come here to buy something. She didn't have a patio set in mind. She didn't come find the thing. She was browsing. Then when you look at her shopping history online, all data that can so easily be tracked through different data sets that you purchase. She's a frequent shopper. At the moment, she's buying a lot. She's buying household goods. Okay. Then we check, let's go check where the order is being delivered. Okay, the order being delivered, if we look at the census data, she lives in an affluent suburban area. We pick up the house address. We look at the house address and see she just bought, the house she's in was sold 6 weeks ago. That is why Belinda's buying patio furniture. She has a pool. We should really start working on selling Belinda a pool. But you start drawing this picture of Belinda, and then you'll see she also clicked on the refer a friend login. So refer a friend option because she wanted $10 off. Okay, so Belinda's also a little bit cheap. So now you have this picture of Belinda. Then you have to build the puzzle and make some decisions about Belinda. If Belinda came to your shop through a Google search, she's a difficult customer. There's no brand loyalty. She's hard to harvest. This is not an easy turning customer. If you wanted to do brand loyalty and all of this, Belinda's not your person. But we do have really good information about how this particular client landed here and how we can get leads. And this is different. The Google search is a whole different data set. Like people's shopping behavior on Amazon and all of that is a different data set. This will be South African census data. This will be South African real estate data. This is our own internal data. This is logs from a server. It's all completely different data sets that we need to bring together to paint the picture. There is no beautiful data set. Okay, where are you guys? Are you okay?
Yeah, all good.
Okay, so is your company doing this? Michael, is your company doing this? Is it aggregating the data around the individual and getting all of that, like, how do you say this? Homogeneous, I can't say that. Homogeneous data to get together.
Yeah, kind of. Kind of. Not quite. I mean, I work in a school, so it's not really retail, kind of.
Also slightly dodgy with kids.
Yes. You know the things.
Yeah, I feel like lawsuit. Don't do that. Don't do this. So, all right. So this is where you have to go, and that is what you look at when you consider data. This is all the kind of data we're going to collect around a single customer to figure out if she's a harvestable customer, unless she's not. Then there's the other thing. Do you build your data or do you buy your data? What do you do? Okay, so how do you decide? Do I actually collect my own data? Do I build my own data? So a good approach that people have is that or a systematic approach that happens is people suck down all the data that they can get for a single source. They get it from APIs, FTPs, they flip and screen scrape. There's stuff like this Fatkin that I use. Somewhere here in Google, there's my plugins. Like I do, where's my extensions? This is going to take long, but I use the Fatkin extension to scrape images of bug poop. We'll explain at a later stage to get as much images as insect frass, which is the correct name, as possible, because I don't want to pay for it. So do we build or do we buy data? And there's something that they're actually not mentioning here, as well as when do we use synthetic data. So there are companies that have calculations about what do we do, like, and they say you have to work it out for yourself. So if you had to say, and the company they're using is a marketing company, if they get $1 a click, they have to go work out what is the likelihood of a click on my own data set and how close do I get to the dollar. If buying an additional data set gets me closer to a click $1, then probably I'll buy a third-party data set. Okay. But if it does not, I will not. And they've got the calculation here for you. They're looking for value. So your value is worked out by your expected value. Like, do I get a click with my own data? And do I get a click without my own data? And they go do these calculations. The calculations in your book, it's really simple. It's just you divide the two by each other. Okay. So you have to decide if you're going to add. But what a lot of people do is they also augment data. So you buy just enough external data to augment your current data. And a good example to give you guys of that is, and you actually don't buy that data in South Africa, it's freely available, but we are one of the few countries that do that. In the education space, you actually get government statistics published about universities and first year intakes of students and how they do over the years. So we as an educational company could very easily only go buy or get the slice of that data to augment our current data. To say, if we really want to understand first years, we have our first year data, which is pretty strong, but we want to pip just this bit from the government data set that will augment our data and make it stronger. And that's often how people decide how to purchase. And other times when it is a really important data set that you want to buy, but it is super duper expensive, this happens, then you can sample. So you can buy a smaller subset of the data, but you have to sample carefully. Because sometimes I will tell you, you have to go and do a random sample. So people always talk about simple random sampling. You choose every odd record to make a recipe for yourself. I'm going to roll a dice at 6. I'm going to choose every 6th record. That's simple random sampling. Super useful for a lot of data, super duper unuseful for qualitative data. Okay, because sometimes qualitative data, the one record feeds into each other. Still, it's the same question you ask yourself here. What value will this give me? What question am I trying to answer? And what data can I either buy or use? And then something that I do a lot that's coming around more and more in the machine learning world is synthetic data. Okay, and it's not discussed in any of the textbooks very nicely yet. So what you do with synthetic data is you go and you go to that very expensive data set and you purchase, say 10% of it. And that will be your seed data. And then you will use that seed data to generate synthetic data. So I've got at least 2 academic articles published where I have used synthetic data and disclosed it. Nobody has miffed at me yet. And we had to explain why we use synthetic data. Because when we originally started working with hydroponic farming, there wasn't enough data sets. We literally could not find any. So we used some synthetic data. But yeah, synthetic data is a real thing that's coming around real fast. You just have to get enough data purchase that matches the underlying statistical properties of a data set, and you can go ahead and do synthetic data. And the last thing when you want to purchase data, you just also look at how securely that data was housed, all of the ethical things about data. Okay. Do you guys have any questions? There's lots of academic articles for anybody that's interested in synthetic data but how to correctly get synthetic data. Yes, Michael.
I know during the PDDA course there on Kaggle there were some data sets that were completely just sort of created. That's not synthetic data, correct?
No, that's not. That's random data.
Okay,
Synthetic,
cool. Okay.
yeah,
Yeah. I'm just trying to make sure that I'm on the same page, because obviously some of those data sets they said the term that they used was synthetic, but basically was completely made up.
Yeah, no, completely made up.
Although it was randomly generated by a machine, which was obviously perfectly fit the normal distribution. But like, yeah. So you're saying that this is sort of a subset of really good data, and then basically just sort of, I don't know,
yeah,
bootstrapped or something. I don't know.
Yes, so I can, and there's definite processes online you can follow for how to generate. I'll look for you now. So what we had is we grow crops in hydroponic tents with AI models, and we couldn't find enough synthetic data for tomatoes or leafy greens. The records that the sets that we could find was too small. So we had tracked temperature, humidity. Look, it's not going to work so well with qualitative data. Quantitative, definitely. We tracked temperature, humidity, light, nutrient solution, pH value in the water, all of that kind of stuff we track. So we got a data set with, I want to say, 4,000 records, and we use that to create actually 10,000 records per thingy, like per temperature, per that. And we followed.
Yes, I'm with you. Yeah.
Yeah, we followed the MIT process. So MIT has a published process on how to do it, and we followed the MIT process to generate that synthetic data. So, and it's been super useful, and the models has been in deployment now for 3 years. So it went okay. All right. Okay. Now,
If it's if it's stupid and it works, it isn't stupid.
100%. Yeah. And it's interesting because the student that ended up doing that as part of her, she was my PDDA student who had to generate the synthetic data. She ended up being such a good PDDA student. And she was a 54-year-old statistician for SARS. So, yeah, I also marked her stuff way on time. Okay, so now that we have spoken about all of this data, do we purchase? What does it look like? How big is it? What is the life cycle? Like, when do we drop? When do we delete? And there's a couple of things here that's interesting to look at. Is we have hot data, cold data, and data that's marked for deletion. So hot data is data that we need very fast. So when we talk about hot data here, the examples I can think about of hot data is if you're going to go look at AWS, and this isn't from your textbook, but I'll show you the Azure one. There's AWS S3, wonderful data storage service, quite pricey. Okay, so if it is data that you need fast, like when you need to, if you have either deleted that data set by accident and you need it returned in flipping minutes, this is where you go. However, if it is data that you don't need to get back in a short time, you're going to look at Glacier, which is significantly cheaper. Okay. But retrieval time can range from minutes to 48 hours. So then you're more careful about which one you use. But when we think about data and where we store it, this massive amount of data that we're going to collect or not collect, we're also going to say, okay, that instantly available, really fast data, we're going to stick on a high, super fast way to access this data. Okay, because data costs. It costs storage, it costs maintenance, there's data acquisition costs, and there's the more difficult costs like data breach costs, reputational damage. All of these things are tied to data costs. So Azure has the archive blob. So there's Azure if you want to make things, I'll call storage blob. So this is where you put your slower stuff that you don't need all the time. Okay. And then you put your fast stuff in the faster places. And then again, I said you have to look at when you must consider some stuff for deletion because data does age and you're not going to keep it. So I wonder if we keep our student data all the way back to when I started. I'm not going to tell you how long ago that was. But the student data that we have, I would say is valuable if we have student data all the way back to 2013. But it's not. We don't need that data immediately. But so we must archive that data and put it somewhere. But to work out trends and how we're moving and how things are shifting and changing, that data is valuable. So that we need to archive. However, real-time test statistics and stuff we have to keep in really low latency areas. Okay, so you really have to think carefully about your cloud offering. And then this brings that conversation about like, what is my core data? Okay, what is my core data that I need every day and fast? That's S3, that's the expensive Azure options, that's a DigitalOcean droplets that is optimized till the 9th degree, that's where we keep that. And then what is my auxiliary data that I still want, that I don't want to delete? What is a low-cost, slower option where we can put this? Okay, and those are the slower guys. And there's an example at the bottom for you that Salesforce doesn't keep a history of a deal for more than 90 days. LinkedIn doesn't keep a data set that's less than 100,000 records. So you have to have the rule of what is this? So we know now what's fast, crucial, core, what is auxiliary, we can wait for it a bit, it's no problem, and what is nuke it. But you have to have a nuke it policy. You have to have rules for when is it considered nuke it. Does any of the organizations that you guys work for have the nuke it rule? Yes, Ephraim, data storage is governed by policies. In this course, you have to be the person that writes the policy. Yes, Michael?
We were keeping student records for like 25 years or something, and then I think Popia, there was a piece of legislation inside Popia or something that basically said we couldn't hold on to that data anymore. We couldn't hold on to student records for more than 10 years. And so we had this enormous truck come and shred all of that information.
Is Popia the authoritative legislation?
I'm not sure. I wasn't really involved at the time when that sort of situation occurred, but basically it was you may only keep up to 10 years.
So spoiler alert, Popia isn't the authoritative legislation.
Yeah, I don't think it was at the time that basically said that we had to, but yeah. There was some other piece of information that we got that basically said you must.
So generally, just for context, you have to keep student records for the lifetime of the student.
Yes, of course. But I mean, this is assuming this was data of students that had left already.
Irrespective, you have to keep academic records for the lifetime of a student.
I don't know. Luckily, I don't do that.
No, but this wasn't academic performance data. This was like, where do they live and who were they and what was their name and all that stuff. Obviously, we kept their academic records.
So
yes.
All right, the do not touchies. Okay, especially for children. Then there is the option of offsite tapes if it's really old data and you want to keep it, and then that's a bad idea, but people still do it. Then those of you, how many of you finished the PDDA? Just raise your hand, don't be ashamed. I know, because I was the Marufa, I was the convener for the course, so I know. Okay. So what is happening more and more that is more and more important is that, how many times am I going to do this? People are no longer storing just data. So in linear regression, we learn 2 coefficients that lets us predict data. You store the coefficients. So what people are doing and what they're going to say to you is that the more data-driven, prepared organizations are starting to store statistical underlying stuff. If you've done, so they say to store the statistical patterns and data, or the learned key features about the data, but we now know that if you've done any machine learning, you store the coefficients or the weights and biases for that data set, and then put the data set somewhere cold, and if you ever need to fiddle with it, bring it back down, but all you need is the underlying statistical pattern of the data. So that is happening rapidly as well. Okay. All right, so those are the things we have to think about with data. And like I said, we're going to look at a case study in a couple of minutes, and we're going to see how all of these things come at play. So now, if we have the data sorted now, so we have these things, we know that we're going to collect contextual data so we can get to this very fine user point. And the example they actually gave here is some shopping carts are super easy. The user wants to shop. The shopping cart is super easy. They load the shopping cart, but then very often abandon it. If the shopping cart is frustrating, it introduces a friction point here, and then the data gathered around there is also interesting. They also look at what they hover over for the shopping cart and all of that to build this Belinda picture. the concept that we have to start gathering data, semantic data, in that way. And that to do that, we have to consider the volume, velocity, and variety of the value of our data. We have to prioritize our data, like what is our quick wins, our must-haves, our nice-to-haves, and the things that we don't keep. And we're looking at return on investment, and return on investment is always sales, revenue, more enrollments, that kind of stuff. We have to find Belinda in the mess, and then we have to decide, am I buying my data, or am I just using my own data? And then where do I put this bloody data, and when do I delete this data? Once we have this sort of together, then we have to go say, okay, now we need to activate. Now we need people to analyze this data. Okay. And there's many types of analysts that we look at. And it's never just one person. It will always be a team of people with overlapping skills. And we're going to look at how you, as someone that's like in strategy in this instance, you have to be the person that builds the team. So what do you look for when you build the team to get these people together? Okay. So in your book, they will have statistics and quants separately, and then all the things I've worked with, they put together, but we'll talk about that. So these are the roles, okay? These are the general roles that you will work with, okay? And there's a beautiful explanation of a data scientist. Remind me that I need to give it to you guys. Okay, so the first thing is you need a data engineering department, and a data engineer is responsible for obtaining, cleaning, munging or wrangling the data into the correct form for the analyst to use. And they maintain that data. So they basically build your pipelines, make sure you have the correct data. They're the person that's going to decide on the data storage units. Where is it? Where do we put it? How do we pull it out? That's their job. Then the data analyst is the one that will go and actually do the initial analysis. And in a lot of cases, a data analyst also still cleans data, okay, and gets it ready. And then your data scientist is the broadest term actually used for the group of people. And they're usually people who are quite good at maths and stats, although not necessarily anymore. And they also have advanced degrees, usually in maths and computer science, although the landscape has changed and we now see lots of degrees in data science that you're looking for in a hire. And they generally should be able to be good at coding, machine learning, and statistics. Then you get the business analyst, who is super duper important, who's the guy who can speak the business language to the techie people and the techie language to the business people so that they can understand each other. So the best business analysts I've ever known have studied fine arts. Nothing techie, it's quite wild. If you go look up some pretty famous one, you'll see that. So they are requirements in elicitation, but also they process improvement, integrate, bring in new features. And then your quant is your specialists. So that's your statisticians, your financial managers. You need these people. Okay, your economists, all of this. And then the way to remember a data scientist is they say a data scientist is better at stats than a software engineer, but better at software engineering than any statistician. It's that mix, and that's why we keep the statisticians in the line. So if you did PDDA, you would have seen actually in SMAR and the statistics module, do you understand the algorithms? And then, you know, the data science role is not deeply understanding those algorithms. It's more applying them. In PDDA, we applied the other algorithms. But in SMAR, you learn the inner workings of that algorithm, exactly how the math behind it works, how it's calculated, and then you can tweak it. And that's where the statisticians people come in. And then how to tweak the algorithm, you need the financial manager, the economist, the domain knowledge people. What is not on this list that is super duper important is visualization people. It's becoming a whole role in itself. WITS has a qualification they're called unicorns. Have you guys ever heard about the WITS qualification in multimedia design?
Can't say I have.
Okay, so they graduate about, 40 students a year. Every industry consultation job I've ever worked on that there was one on, it was just phenomenal. So they are trained in graphics almost to the equal part that are to coding. So they create like visualizations of data that people actually want to see and look at. And they have enough artistic background to know which coloring and things to use to make the right data pop, but enough coding background to make that a viable product for a company. That is also a person. This whole visualization, the data visualization person, is becoming a role completely within itself. It's becoming a
So it's
hire
paint by
that you will look
numbers?
for. Yes, it's paint by numbers, but valuable paint for nice numbers. Okay, because people don't look at ugly data. That's the other thing. You all like we all like pretty slides, we all like things given to us in a digestible format, and they're just uniquely trained to give stuff in that digestible format. Okay. However, you have to look at this kind of stuff. You have to look at the T-shaped skill set. Okay. So for any one of these, they'll have their T, except for two positions, which is called a pie, because it's like the slices of a pie. We are not the most clever people. So T knowledge is you have a breadth of general knowledge, but it's not very deep. Okay, so that's your breadth of knowledge. And then there is your T, the deep, your specialization in what you are very, very good. So you'll have entry-level information here, enough to survive, but here will sit your value. And here they're going to show you how that translates. Here's people's T's. So the business persons, this is their deepest T. Do you see that? And for the data researcher, statistics is their deepest T, and they actually have the least of the T there. And then there's two positions here that are not very T-like. Okay, and that's a data creative and a data developer. They are not very T-like. This one is the least T-like, and they're called pie positions because they have skills in almost equal measure, like sort of in a pie chart. But this is something you have to consider because this person needs the T. Your data business person who looks like this is not useful to you. You need the T person here. Your data researcher, or the person that's super important to draw your data, put it together, understand the hidden meanings, needs this T. These two are generalists, float around. They don't need that T. They've got their own blend, but they don't need that deep T shape. So when you are looking at people, when you're looking to put your team together, you have to understand that T. Okay. And then you get to play Tetris. Oh, I've mixed these slides up. Okay, never mind. So what is the anatomy of a great data scientist? This is what you want to put. It would date any one of those analytical roles. So it is massively team oriented. It is not in any way unique. So you're going to look at them in three different ways. You're going to look at them individually, team orientation, and work orientation. So individual, are they a fit for your company? Is this a person your people actually want to work with? Okay, team-wise, do they complement your team? So, and we're going to come look at this now. What does their T look like? Okay, do they complement your team? And then work, are they a profile match? Is it actually what you are looking for? And then the skills that you are looking for is people that are numerate, skeptical, can easily pick up a sense for bad data. And that skepticism is super important. They have to constantly question data. You're not going to go like it is what it is. You don't want it is what it is people. You want but why people. We've spoken to this at length. They have to be a storyteller that can explain complex models to non-experts. They need to be curious and passionate. And this is super important stuff that you would think this is soft stuff. But if it's not, if a person who's working as an analyst does not dig in stuff for fun, if it's not something that's innate to them, that they want to know what's in there, they're not going to work in this role. And then we have to have the business savvy. The IT exists to serve business. No other reason. If there was no corporations, there'd be no technology. It's why it exists. So you have to focus on return on investment. You can't go on some rough edge case. Okay. And then the other thing is patience and an aptitude for learning. That is what you interview for. And then you look for skills. Okay. Then the other thing is, what is their tooling like? People will tell you that toolkits don't matter. Like, have you guys ever heard the thing about, oh, they say it in education all the time, and it drives me bloody dilly. So when I have to take a class and they teach it, and I go like, why are you teaching it on this? They will, can we give our data team T-shirts to easily? Yes, you can print it for them, Barry, and then also pay for the shrink. When I used to teach, well, I still teach a lot of programming, but then, like I said, 2 lives, do a lot of industry work. So I would ask the question, why are we teaching Java on NetBeans? It is old. Why are we doing this? And they'd go like, oh, but the principles remain the same. Ephraim, have you heard this argument? Riku, Michael, the people in the education spot, have you heard like, oh, but the principles remain the same? Have you ever heard this? We're teaching the principles of programming.
I heard a teacher say this about Delphi because it got sent to like the principals, and it was like, why are we still using Delphi? And then it basically boiled down to the Department of Education still requires it because that's just what they want.
Yeah,
might as well be using Turbo Pascal.
Yeah, flipping hell. But yeah, I know the schools teach Delphi because then they'd come into the Java class, and it's also disproportionate in South Africa. Some schools teach Delphi and some of them teach Java. However, when these kids go to work, they're not going to use NetBeans. So tooling matters. Your skills and toolkits matter. So this is a survey that was done. So look at the difference in salary and tooling. So Barry, you work for Advitech IT. Do you guys ask, what is your Azure skills like? How are you with SQL? Or do you ask, like, do you understand databases in general? What do you ask?
The tooling is quite important. We've obviously got our own tool set that we use, so experience in that tool set is quite important. However, if there are parallel tools that do roughly the same thing conceptually or whatever, we can afford opportunity to learn our tool set. However, experience on the actual tool set is preferred.
Yeah, so actually your salary increases greatly with tooling. So you want to look at the tooling, and then why they don't have a specific set of tooling is because it's different for every company. Like Barry said, everybody has a different set of tooling that they use. So if you are well versed in different tools, you will be more profitable, but also an easier hire, and you are looking for someone that fits your tooling. Okay, but also who knows like how to apply the tooling and where to apply the tooling and where not, like smart with tooling. Okay, so tooling is really important. So there is the just one more tool thing that people talk about, and the just one more tool thing is right. There's always just one more tool that you can learn and that you want your data scientists to have, and you should have frequent upskilling on tooling as well. All right, so this is how you play Tetris. Okay, so if you want to build your data analysis team, here's their T's. They all have to have different T's. If all their T's start looking the same, you've made a boo-boo. Okay, that's not great. You need people with the right T's and the right blend of stuff. And in your textbook, if you want to go read this, these are actually staff members. I want to say they worked for Nordstrom in the States, and this was their blend. And then what is the size of the team is also often a question. And there's Jeff Bezos' 2 pizza rules that says if 2 pizzas can't feed the team, it's too big. So you're looking for 5 to 8 people because you're looking for agility. You're looking, and this is a weird thing that's interesting, is you're wanting to reduce groupthink. And what do you guys think about when I say that you in this spot, you want to reduce groupthink? Does it feel like a good or a bad thing?
It depends on the context. So you don't want to have people who are indoctrinated, but you also don't want to have people who are too off the beaten path.
Yeah. 100%. You don't want indoctrinated people, but you don't want the crazy person either. Yes, okay, Michael, that's true. In South Africa, it's probably a 15-team person for the size of the American pizzas. Right. So yeah, and you want to reduce groupthink because you don't want people to follow the trend. You want people to be critical about data and to ask the questions. But Barry is very right that you should also just be careful for the psychopath. But groupthink makes people agree and sometimes groupthink is very dangerous when they start following the highest payer, because that also happens. So that's why you have to have your blend and why you keep your smaller teams. And then do the blend that your company needs, but make sure that you play Tetris so that they fit nicely. Okay, so don't hire for the individual, hire to fill the gaps in the team's rectangle. Like, where is the blocky not lacquer? Hire there. And like clearly here we can see Jason is the business dude. Okay, clearly you can see Jim is a data analyst. here you can see Erin is the visualization person. She's got some ML skills, and this is why that WITS degree is such a powerhouse and we should steal it. Okay, because she has enough to do that visualization really, really well. And then I don't know what David is. What do you guys think David is? He's got business, he's got some programming, he's got some maths and some DevOps. But that's how you put your team together. You play this Tetris thing.
He's probably a bit of the devil's advocate or the chairman of the team.
Yeah, he's the manager. Okay.
Definitely.
Incidentally, we did something similar
Yeah.
like that in Andrew's class.
Oh, you did. Did he show
Yeah.
you the matrix with the spider diagram of the self-reported skills?
Yes, he did.
Oh yeah, I've been through that. Okay. And it is valuable and it is very much used. And then there's also the things that they do when you report your skill, like, are you a novice? I'm still learning. But actually, where we look for expert level is I can teach others. But that's in Andrew's course. All right. Once again, what do we do? And we've spoken about this before. Actually, centralized is, and I know here it says hybrid is recommended. We're moving there. But if you have your data analysis team, where do you put them in the organization? We spoke about this a bit before. If they are centralized, you can standardize skills. It's easy to do training. You reduce licensing costs for stuff. It's easy to promote the use of the same analytical skills, but what's important, what happens in that is that's not all that we chase. We really chase communication, mentorship, like-minded conversations, because really good things come out of there. Okay, there is, however, a chance that you can lose objectivity. So you have to just be aware of that. 63% of the most big data companies with the most successful tools, like the Amazons in the world, they sit centralized. Decentralized teams is where we put the data analysis in sales, data analysis in HR. It gives speed. Okay, things are a lot faster, but they are removed from other analysts. They don't have the cooler conversations. That is interesting. And the latest research has found that it didn't result in more domain knowledge. They're still a data analyst. They didn't become an HR specialist. Even though they work consistently with HR data, the skills they needed was analyst data. That's what they are. So they didn't learn a lot more about HR. And then we're moving to put the guild or a hybrid system. What is interesting, how this is starting to work, which I found interesting, is that they're starting to do a consultancy model where you actually have a data analyst team in the business, but the partners book them out to consult to them. And then they stay centralized, but they go work in the department for a little bit and come back. That seems to be working quite nice. And this is where a lot of companies are slowly starting to move to. Not enough data on how good that is yet. So what did we learn today? We have to look at data and people. So you have to collect the context, not just the transactions. And we're going to look at that case study. You have to prioritize your data based on return on all right. It's important to build the narratives, hire the correct T-shaped players, and organize your department for speed. Right. Now, do you guys want to take a 5-minute break? And we're going to go through that case study, and we're going to look at what we can identify from what we've learned in these slides in the case study, where they have done it, where we can see it happening. But I think let's get back here at 8:10, and you guys take a 5-minute break to just remember who you are and what you are, and I'll see you in 5 minutes. Deal? Okay, are you guys ready to start? You can just
Yep.
do a reaction and like show that you're alive.
We are here.
I've just muted myself with this bloody mic, with this bloody touchpad. Okay, no, Zippo, I have to find ways to pick on you, so I'm going to go look you up so that I can call you into the conversation. So we are going to look at a case study, you guys, which is the Provincial Health Data Center for the Western Cape. So I came across this when I was invited to a digital health symposium that was hosted by the Hasna Plattner Institute. And one of the most interesting speakers was actually the guy from the health department in the Western Cape. A, he swore like a sailor through his whole presentation, which was very refreshing. But B, he introduced and spoke about this at length, and that led me into a very deep rabbit hole of looking into this system. But because I'm cognizant that you are all working people that don't have a lot of time to read, I have done this. I have gone and I have asked Notebook LLM to make you a quick video, and it's quite, I've watched the whole video and compared it to the article I linked for you guys for this. That gives you the information. But I've also made a short summary for you guys that highlights what we're going to discuss about this case study. Okay, so many ways. And there's also the slides that we're going to look at now. All right, let me just see which slides I linked, because sometimes I link the wrong slides. Oh, it's the right slides. Okay. So this is the Provincial Health Data Center of the Western Cape. It's active, it's running. Sometimes it's nice to have hope in South Africa. Okay, so what is this? What happened? So basically, the Western Cape has a lot of stabbings and violent crime. And they had issues with clinical care. Okay, they didn't have integrated patient level information. They didn't have an operational health system intelligence that could help them manage and plan, especially for epidemiology with COVID. And they had nothing to support research. And because they have a lot of infectious disease in Cape Town, and we all think about Cape Town as the Europe of Africa. But actually, the HIV stats there is still quite horrendous, and the TB stats there is still quite horrendous. If you leave just outside of Cape Town, you're going to see Langa, you're going to see places like Philippi, where you can't even drive into because you're likely to be shot. And we've all heard the news about people in and around Cape Town being shot and the gang violence as soon as you leave the beautiful Europey spot. And that had a massive burden on the ER departments. Okay, so then they started to put, actually this took them 10 years to build, so they didn't do this very quickly. But this is what it does. It transforms fragmented healthcare data into actionable intelligence through two core differentiators, okay? It is a single unified architecture that seamlessly services both named clinical care requirements and anonymized public health research. So they've gone and they've said, yes, we need to fix health, but we also need to support research. So we're going to do it in such a way that doctors can still find their clients, but if a researcher needs information, they can get it. But it's also a multi-source data inference machine because it gets its data from clinics, hospitals, pharmacies, labs. That painting Belinda, they started painting a picture. They use this the sources of information to accurately find out personal level for a patient and actually track that patient through their health offering. Okay, so this is the scale and setting. Okay, there's 7 million inhabitants in the Western Cape. 15 million patients contacts go through it annually. They're working with 52 hospitals and 354 clinics. The system currently handles 8 million active unique patients linked via PMI, which is a patient master index, which is a number that's assigned to each patient so they can track them through the system. So this is where they are at and what they are starting to do. Okay, so here is their high-level architecture of what they have built. Okay, you don't have to understand the architecture, don't worry. Okay, but basically what they did is they're getting information from all of these places. Okay. That then goes into a staging and holding area, and then that data gets transformed and cleaned. So they have a very structured way of handling their data so that they can actually interconnect all of the different data. Okay, so they end up with the Belinda picture, but very, very easily. So in the past, they had worked with aggregated data, like the number of cases of COVID. they've moved through this shift to this is a person with COVID and actively tracking with COVID, because they found with TB, tracking the number of TB cases was super unuseful. They didn't end up solving their TB issue at all, because when a patient dropped out of care, they didn't even know who it was. They will just find the active cases just hanging around there. But when they moved the individual tracking, they could figure the actual patient that fell out of care and get them before we hit all sorts of drug-resistant grossness. Okay. So,
Sarina,
what?
just a
Yeah.
question. That's OpenHIM under the
Yes.
import and archiving. Is that what the surgery department uses?
Yeah, it's what their surgery department uses. How do you know?
Well, they
Oh,
open
no,
him.
man. No, Barry, but him as a medical, but yeah, no. It's not. That's interesting. You said that him is a medical platform for data usage, but I see what you mean. Okay, okay. All right. Consider me schooled in both ways. All right. So they have this unified architecture that they use to create a unified patient narrative. So they track from clinics, they track admissions, discharges, transfers. Okay. Then from laboratories, they track pathology results, and they use that to monitor chronic disease and outbreaks in epidemiology. And then from pharmacy, they track medication and dispensing, and that lets them see if a patient is staying in treatment or not. And they actually use pharmacy. They use pharmacy in a really interesting measles case as well. So what happens is a patient comes to the clinic for the first time and they're given their PMI number. They PMI number is then used to track them out throughout the system, and they actually store stuff in different databases. We'll talk about that in a minute. But then they had to decide, remember what I said, when you want to collect all of this data, because we're not collecting all the data, you have to have a game plan. And one thing they did really well was a strong game plan. And they took international standards, which we should all do. Okay, so what they did is they were like, all right, anything that comes out of clinic, we work with ICD-10 codes. Okay, so when the doctor diagnoses, he needs to give an ICD-10 code, because then we can pick up blood glucose, and blood sugar is the same thing, because the doctor has to assign the same ICD-10 code. Anything that comes out of pharmacy uses the pharmacy's code. I've written it down. I'll find it in a minute. And anything that comes out of laboratory uses the laboratory universally and internationally recognized laboratory numbers for tests, so we can know what kind of tests was done. Okay, so they then harvest all of this information and they put it in an extract, transfer, load model. And you can see here is our extract. Here is our transfer, transform, and here is our load, where that becomes available to doctors as well as researchers. So you have a single patient viewer that shows you medical data for every person in the system in Cape Town right now. It was super cool to see it. Operational reporting, active surveillance alerts if TB patients particularly drop off medication for TB, so that's picked up really, really quickly. And then some bespoke extracts that they can use. And then it also gives them like business intelligence that's really, really useful. So that's the structure that they're using. And do you see the parallels about the things that we've learned? Because there's their linkage engine. Like, we have to bring all of this together. So to get all of the data about one specific patient, we need their labs, we need their clinician, we need their pharmacy. And the 9-digit folder number of the PMI code has a modulus 10 checksum, meaning they can't be duplicated, they can't be fiddled with, they're fairly safe. But they also use fuzzy text comparison, so that if it's Smith Day or Smith John, to be able to pull up the correct information with fuzzy logic. Okay, so that and fuzzy logic searches are still pretty useful today. So how they use this thing and what has been happening is this. They have, hold on, this, where they have harmonization. So they get that data, okay, and they put it in different silos where it should stay. Then they bring it back and they map. And they're like, okay, so we have to use the ICD-10 codes for diagnosis, the LOINC codes for diagnostic tests, and I think it's TBA or TRA codes for pharmacy, so that we can actually use this information to see if we have a health encounter that will reach us to an episode that cascades through the system. Okay, so they have this, get all of this really data from very different places into one place, transform that data into one unified structure that we can use it, and then get benefication out of it. Get that longitudinal patient narratives, paint Belinda. Okay. And that brought about this thing, okay, which is the inference paradigm. So what that will tell them, and we're going to look at some records here. What the system does for them is it has confidence levels, and it's set up quite carefully so we cannot make a mistake. So the example that we're looking at here is the system will pick up that they have done a rhesus antibody test, okay? But a rhesus antibody test alone is just a supporting record. It doesn't mean someone is pregnant. But the system will think in its head and go like, there's a rhesus test, okay? Let me check if there's an ICD-10 code, okay? Or let me check the clinic if there's iron and folate dispensed. Let me see if there was a live birth. And then we create that record that we actually had a pregnancy incident. And we can do it with confidence, because the confidence goes stronger and stronger the more we have to support that record. And we can say, we are starting a medical episode. This patient absolutely is pregnant, has had a baby. And listen, you guys, I do a lot of research in digital maternal and child health. A lot of South African mothers don't access like in hospital care. It's too expensive, not for births, but while they are pregnant, lots of them miss those maternal care appointments. So you very actually only find out that we have that baby at 40 weeks. She gave a live birth. Okay. But now the system can know flag for baby wellness tech. Okay. There is a system that they enroll all mothers on in South Africa called Mom Connect. Get this mother on Mom Connect, get her linked up to the closest clinic, get antenatal, prenatal, whatever, the baby care, the wellness baby care for this mother. So what it will do is it will say, I have high confidence that this was a pregnancy, or this is high confidence that, or like a TB test. Okay. When it sees the TB test, if it sees the referral to clinic, it's going to start being, okay, we are looking at an incident of TB coming around here. Okay, and then they start following the patient's history, and then they can track, like, if there is an episode or a diagnosis, is there any comorbidities? How is retention and care going? Is the person staying in the system or dropping out? How important is that for disease control? If it is something that has epidemiological issues, and then what is the outcomes in the end? And something that happened in 2013 is it's harder for them to track when the person has just died, because we've changed the legislation on how to report on deaths. And they have an article on that, like, shit, now our system's broken because it's hard to figure out if people had died. This gives them 3 benefits: rapid information discovery, tracking of the care trajectory of the patient, and it gives them identification of a fallen out patient, which is important to know. Because of this, they have this cascade linked to care, retained on treatment, health outcome evaluated. This is this amount of information that they're running with concurrently. So they're dealing with 433,000 HIV patients in care annually, 500,000 hypertension episodes that the system tracks for them, 235,000 diabetes episodes, 110,000 annual pregnancies. There's a lot more, but the system picks all of this up for them and tracks it for them. Then it is built with Barry, Ewan, and Michael's conversation. It's built with all of this stuff in place. It is built with security by design. So what is really important to know is that the patient identifiers are stored in a different database than the clinician information about the patient, in 2 separate databases, and they adhere to strict operational sharing overhead. They are governed by the Presidential Health Research Committee. They have to have explicit patient consent for research data. And the linkages are hidden anonymous keys, and the automatic application logging and strict audit trails, meaning if anybody tries to pull a record about a patient, it's automatically logged. And if you were not like the person who should be pulling that record, it was known to the system. And it allows us to anonymize unique identifiers for medical research, which is super duper important. And that gives them, it doesn't look like this, although, but that gives them the single patient viewer, that is a web-based portal showing a rapid clinical discovery. And it's, you can see per patient, or you can see per TB, or you can see it gives them where there's a gap, it gives them actionable clinician data, and it's based on longitudinal data over 10 years that can help clinicians make decisions. Right, it has active surveillance in it. I think that's pretty cool. So if they pick up for things like COVID, monkeypox, and we see these blips in the news where these little things are happening in South Africa, and they really don't become full things after COVID, or at least in Cape Town, because they have this. So what will happen is if there is CRE exposure alerts, like anything that's bad that could get into the whole country, it will trigger an alert, it will let the right doctor know, and it will start targeted delivery of the information, find the patient. Don't know how much I feel about that, and find a prevention officer to find that person and help them. Right, it supports research. You have 50 annual releases of anonymized data that people can use for a search. It's de-identified and classified. It's put through an anonymization machine. So very supportive in that way. And these are the lessons that they report on in that article. Okay, so they tell you that they're prioritizing operational value over extractive research, ensures system buy-in and data. So researchers wanted this and it never came up, but the minute it became, the ROI was high, it's useful in the health sense, it's delivering value to the Cape government, the funding came. So instead of looking at a system to track research, they looked at a system for direct clinical support, accurate analytics and research outputs followed, and then they had provider buy-in and high data input. Okay. So they're saying here, data immediately impacts individual patient care. The PHDC avoids the pitfalls of parallel extractive surveillance systems. So it can feed research at the exact same time. And this is the bit that's interesting, that it is a very imperfect environment that they're working with. And that they were saying, like, the number one thing that was important was pragmatism and human capital. So it wasn't tooling. It wasn't like tooling is important. We've said that. It wasn't that. But what they figured out was this shift from aggregate reporting, like 5,000 TB cases, to individual data. You had to invest in in-house data science capabilities, moving beyond traditional IT roles and looking at skills that doesn't even exist yet. And it highlighted how much different roles there should be in a setup like this. Okay, this is where they want to go. So they want this to become a whole of society intelligence program. We're hoping it will eventually hit the other provinces, but they will basically, you will have an electronic medical record that can be used for your clinician data all over the country for widespread efficiency. And then we can have cross-sectoral data sharing, hopefully not with Discovery for my diabetes tests, but then we can have whole of South Africa society interventions. And we'll look at more things about this, but this system is live, active, and running in the Western Cape. They have super cool models running. They're doing really interesting things. I didn't expect this when I went into that talk. I was expecting the guy to be really boring. So it was quite an interesting surprise when they ripped this out. And this is like the beginnings. There's a lot of data learnings we can have from this case study. I'm trying to find where I've written down that key for pharmacy. Can't find it. Are you guys still awake?
Yes.
All good?
Do you see the
Yep.
parallels in this system and the slides that we just discussed? What similarities can you draw? Type them in the chat if you don't want to talk. What similarities between what we just talked about strategically is a good way to do things is in this case study? What are you seeing? Must I make that an ice task? You guys don't have ice tasks.
Well, the takeaway for me was not to aggregate the data, to have that individualized data set had a lot more value, and you could target your approach a lot better. But maybe I'm misunderstanding the question.
No, that's correct. It is the individualized data, because the individualized data feeds aggregate data in a lot better way as well. So, and what they did really well is they stuck to the rules, like where they stored their data, what is cold and what is hot is really strong. That will come later. But when in their inference engine or in their this thingy, to get this whole system to work, they had to get this bit right. Okay, like how do we clean this data? and move it into the system so it can work. And deciding on having a strategy for this is what our data will look like was super important, because now that they have ICD-10 codes, it's an ATC code, and LOINC codes, it's super easy for them to integrate their data. So they thought about, we will have masses of data from different sources, so we better have a singular structure that we use so that we can whack or integrate this data in together. We know velocity. We're looking at velocity. We know what, it's not a problem. It's a pregnancy. We'll log it. We'll get a care. It's a TB patient off the radar alert. So we know which data needs to have high velocity, which data needs to have low velocity. They've looked at all of these things. What gives us value? Individualized data. And how do I build that individualized picture? And they really focus on security and stuff from the get-go. So access is based on a need to make node data. It's encrypted, and they obviously have lots of logging happening in the system. And they invested heavily in human capital, and that will be another one that we'll look at a bit later. You'll see we have more work to do. But they invested heavily in human capital, and skills. And they did their hiring right. And now I think I have run out of words, and I'm definitely no longer to formulate them, as it is clear. Are you guys okay? Are you understand that this makes sense? You're not feeling like you've stuck your head in a bee's nest or anything like that?
We're okay, thank you.
You mean a
Okay.
DB's nest?
In a DB's nest, yeah. So you don't want to cry and run away. All right, so just so you guys know, this was chapter 3 and 4 in your textbook, and in the next class we'll look at chapter 5 of 6, and from now on we're going to pull this case study in and look at the differences, the narratives, the things that's coming out. And I think as South Africans we can be very proud that we got this right and running so well. It must just hit the poorer provinces like where I live. So, yeah. Right, like I said, the assessment will be available on Friday so that you guys can look at it, and then in next week's class, how you can ask me questions. The assessment is in no way meant to trick you, so don't worry if it's just do the work. Okay, it's not a, yep, Marufa?
Oh, the assessment or the assignment, because I saw the assignment is already up already.
They've loaded an assignment? Let me go have a look. That worries me
Yes,
greatly.
yeah.
Okay.
Assignment 1 is up already.
Okay. What assignment is that?
Let me see if I can.
I think I've loaded the wrong assignment because I'm supposed to set the assignment. Well, I have set the assignment, but I need to. Yeah, but let me just go see what they've done. What am I looking for? My emails.
And the student material, I saw it. Unless if I am.
But if are you smoking your socks?
I'm not. I swear.
I
I'm still
can't.
working on the
I
assignment,
saw it.
Sarina.
This.
Huh? Yeah, I need to be sure that assignment is like lit.
But and it's not me.
It's not you. I need to make sure that it's a good assignment, because there's nothing worse than working on a boring assignment, and there's nothing worse than working your butt off on an assignment that doesn't make sense. So I just want to make sure. Did you know? Marifa, if you find it, send it to me, because in no way. What the hell?
You see? Oh, I'm sorry, Sarina. I didn't even ask to share. Here it is.
Okay, I see it. I will go ask. Oh, we also have Sitim here in our course. What is this? Let me see what they've uploaded here. Oh, I did it.
Oh, Jesus Christ.
I've already looked at it. I was planning to start working on it this weekend.
Now you can work and submit.
No, man, isn't this? I didn't upload this. Okay, I'm gonna go ask what this is.
Oh, Rupa, you have the wrong assignment.
Do I have the wrong
Yeah.
assignment?
Yeah, this is not the assignment I said. That doesn't mean it's the wrong assignment, but let me just go through it. No, this is not the assignment I said.
Okay. No, then it's a good thing I asked.
Yes, it's a very good thing you ask. No, this is not mine. This is also the bolding here is interesting. Okay, I will ask about this. This is weird. Okay. Okay, no, that's weird. All right, no, please ignore this.
Oh, thank you.
Okay, please ignore this. Okay, the correct one will be out by Friday, and then we will go through it in detail. I don't know whose assignment this is. Yeah.
And Serena, I didn't see you in our WhatsApp group for masters.
You guys have a WhatsApp group?
Yes, we've had it since last year.
Is it a happy place? Do you guys have happy conversations and share nice memes? Or I'm going to get a message 9 o'clock at night going like, oh, this is difficult. I want to drink.
It's it's an okay place. I think it's not very busy, but because I think maybe if you wanted to say something to all of us, maybe that would be easier.
Okay, I will ask Kafeni to add me to the thingy, to the WhatsApp group.
Okay, thanks.
Okay, sorry about that assignment. I don't know who uploaded that, and that's exactly what I wanted to avoid because this is like, man. So let me go find out what happened here, and why this assignment was loaded. Because yeah, this is not application. Okay, I'm gonna go find out, and I will let you know.
Someone's going to
I've
be in
added you to the group.
trouble.
I think so. Yeah, because I don't know who did this assignment. So, and I was wondering why no one is screaming at me. Yeah. Okay, I will get a hold of Afeni and ask her what is this.
Okay, thank you.
Okay. All right. Guys, I will see you next week when we have demystified who have uploaded this assignment. And I will upload the correct assignment. Okay. Also, the rubrics cut off in half there. All right.
Okay,
So,
thank you.
no problem. Chat to you soon. Bye, everyone.
The cool presentations. Or maybe you can give us a short video. I don't know.
No, man. All you're going to do is this. You're going to go to Notebook LLM, né? And then you're going to say, try Notebook LLM. You all get access to Gemini. Did you guys see this thing? You need this. Student access Gemini Pro free.
You're not sharing screen if you want to do that.
I'm sorry. Okay. So let me just share my screen. Okay. All right. The first thing that you want is you want to go sign up for Gemini Pro with your student number. Okay. So you will get a year free Gemini Pro as a student. Super duper helpful. Okay, and I think you can renew it every year. So sign up for that because that then means, again, that then means you get access to Notebook LLM. So I'm just going to say create a new notebook. And now you're going to think, now all my magic prep for my class. Should I show you guys my devious ways? So I'm going to go say create a new notebook. It's just important that you check the stuff that comes out of here. Okay, you can't just rotate it. You have to take a look. So I'm going to upload a file. What is in your download, Serena? Is there bad things in here? So let's upload this because I have to work with that actually. So it's going to take the PDF and upload it. I haven't done enough work on this. Hey, I'm lazy. So I just then come and tell it, you can upload one source, multiple sources. So I go find all the sources that I want to work together, all the examples. I save it all as PDF. Or sometimes I give it a web link. But I go find all the sources that I want to inform your material. I put it all in here. And then I tell it, make a slide deck, make a video. Or select, because I don't know what this crap means. Make flashcards, make an infographic, and it's going to make the most beautiful slides for you. Then I download them in PPT format, and I go through them and make sure I'm happy with what it's generated, because it can do weird stuff. And then if I don't have to make any changes, I come in here and download the PDF and upload it for you guys. So this makes gorgeous slides. You just have to check them, and you have to check the order, because sometimes it hoists them in a strange order. So you have to go do your planning and then just come back that it hasn't put a slide in a different place. But that is it. It's going to make those slides for you. I have an example for the stats class I did on evaluation metrics. You'll see here's all the stuff. Chick, chick. This is an example of one I did for the OLS regression metrics, but I didn't like this one, so I'm going to go, this is really boring. But just how to work out the different evaluation metrics to go with that spreadsheet Marufa that I use with you guys in class. And I literally, listen, this thing is good. I literally just uploaded these things. Okay. So I just gave it a data set and my pictures and a whole lot of stuff. I just gave it my stuff. And I was like, make it. And it made it. And it takes a couple of minutes. So those of you that lecture, listen, hit this for work, hit it, because I cannot make slides this good. And there's this meme from this. Yes. I want AI to do my laundry and dishes. Have you guys seen this? Oh, this is the time of night where this happens. So, and this is I keep this in my heart. Okay, so I want AI to do my laundry and dishes so I can do art and writing, not for AI to do my art and writing so I can do laundry and dishes. I want AI to make my slides so I can work together my lecture. I don't want AI to deliver my lecture so I can build the slides. This is how AI should be used. This is how the lens we should always have. Make it do the heavy lifting. There's no reason not to. So hit Notebook LLM. Barry, how deeply have you used Gamma? You guys be my share tools, hey? There's no if you find it, share it. I'm going to take a look at Gamma. So if you find a cool AI tool, share it and share Notebook LLM with everybody, and please use it for your slides and use it to do all your stuff.
Right. Yeah, I uploaded some infographics in the class yesterday.
Michael, I don't like paid versions. I grew up in the time that you could steal license keys. You know, that was my reality. I miss it so badly.
Yeah, but sometimes the source is behind the paywall. You just got to give a little bit of sugar.
Yeah, I know. I pay for ChatGPT. I confess. Okay, I do. But I am not going to manually write out those formulas.
I think it's like $4 or something for a month. It's not like grossly expensive, I think.
Yeah. I pay for Writeful for research, but I am not going to manually ever in my life put a formula in Excel again.
And there's a 7-day trial or something on Gamma, and it's so obviously it wants your credit card details and all that stuff, but like do the stuff for the 7-day free trial once you've signed up, and then have a look.
Okay, so this is the solemn agreement we all have in this class. So now I've given you Notebook LLM and free Gemini. Go signed up. Michael has given us Gamma. And the next class, somebody bring a tool that you use that makes your life better.
We had to do a presentation for, I think, not security. It was for strategic management, or I can't remember what it was called. But my document was like something like 96 pages or something in the end, and I didn't know what the hell to do with it because we then had to make a presentation. So I yeeted that stuff into Gamma, and out the stuff came.
Okay. Yeah, so I am actually, that's interesting that where the AI space is going. So I am a papers chair for a couple of conferences where, people submit their research, and then the papers chair is the one responsible for making sure the research gets reviewed and we follow all the ethical standards and all of these things. And in the last year, our statement has changed on like fully disclose your use of LLMs, blah, 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 blah. It is now like only if you've used an LLM for anything other than language, grammar, condensing your document, tell us about it. Otherwise, we don't care. So it's an interesting space we're entering from, you have to write a 7-page motivation for your use of an LLM, like IR Afrikaner is not enough. It's completely gone now. It's now like, please use LLMs for grammar. It's no problem.
And please, for condensation, because I repeat myself like 50,000 times, and then you realize you can chuck it into AI and it cuts 4 pages down into like a half a page.
Yeah. So, and all of that is just structuring your writing. It's still something you've written. So the whole academic world at large.
100%, 100%.
And UCT has completely stopped AI tracking, hey? So,
Yeah, they.
yeah.
I don't know. Yeah, maybe I don't know. I don't know. I don't know. I think they it was probably too expensive for them to figure it out. Yeah. Scraps flawed AI detectors. Yeah, because the next thing you accuse a student of using AI when they didn't, and then and then you're in big trouble. Yeah.
Yeah. It's interesting. Like I have a colleague, Abraham, he loves dashes. He loves them. So now we were like, oh, EB, you're in so much trouble. You can't use dashes anymore. And I mean, he's used dashes since I started working with him in 2013. I'm like, oh, dashes are dead to you now. We can't touch them. Because dashes now means ChatGPT and random bolds means Gemini. Okay. Right, guys, I will see you next week where we're looking at the last, chapter 5 and 6. Then learning unit 4, actually we jumped to chapter 9 because that's deep decision making and critical thinking stuff. But this course only has 5 learning units, so there's about 2 nights per learning unit. So we're pacing well, and I will fix what happened with that assignment, and I will get the correct one uploaded. I just want the assignment to be meaningful and to actually let you practice your skills, because that's what assessments are for. Anyway, formative. So summative is to mark you, formative is for you to practice your skills. Now I'm going to go pour a glass of wine. Have a lovely evening, everybody. And I will see you next week.
Thank you, you too.
Thank you very much. Have a good
Bye,
evening.
everyone. Have
Cheerio.
a good evening. Bye.